Okay, welcome. I'm going to go through the solution for quiz 2. First question asks us to find the range of a function. So what I'm going to do is I'm going to start by writing down the range for one part of the function. So let's start with the range of arc cosine. In order to define the inverse cosine function, we needed to restrict the domain of the cosine function to be between 0 and pi. The range of the inverse function is the same with the domain of the original function, and that means that the range of arc cos, inverse cos, is 0 less than or equal to arc cosine of x less than or equal to pi. Cannot output any angles except the angles that are between 0 and pi. Now that arc cos in the middle, I want to build the -1 plus 3 e to the 2 arc cos of x. I want to build that in the middle. In order to do that, whatever manipulation I apply to the middle has to be applied to the other sides. First manipulation, that arc cos needs to be multiplied by 2, because in the exponent up there it's multiplied by 2. So I have 0 times 2, which is, what am I doing? 0 times 2 is 0, less than or equal to 2 arc cos of x less than or equal to 2 pi. Okay, next step, I'm going to exponentiate. Okay, I'm going to raise both sides as powers on all three sides as powers on a base of e. So e to the 0 less than or equal to e to the 2 arc cosine of x less than or equal to e to the 2 pi. E to the 0 is 1. Okay, so the inequality is this so far. We're getting close to constructing the function in the middle. We need to multiply everything by 3. And then the last step, I'm going to subtract 1 from everything. So I'll have 2 less than or equal to -1 plus 3e to the 2 arc cos of x less than or equal to -1 plus 3e to the 2 pi. Now that we have the function in the middle, we have this inequality that says the function in the middle is larger than or equal to 2 and less than or equal to -1 plus 3e to the 2 pi. So thus, the range of possible y values is square bracket, because the end point is included, 2 comma -1 plus 3 e to the 2 pi, and square bracket because that endpoint is included too. Okay, second question asks us for the domain of f of x equals the ln of -2 plus e to the 5x. First thing to note is that ln of a has domain 0 less than a less than infinity. You cannot plug negatives and you cannot plug 0 into a log function. So it doesn't matter what I have inside that function there. That's essentially a. Now I'm going to embed that into this inequality. Okay. Now, for domain, what we want to do is we want to get a statement about x. What does x have to be between? And that means we need to isolate for x in the middle. I'm going to continue by adding 2 to all three pieces. So I'll have 2 less than e to the 5x less than infinity plus 2. Infinity plus 2 is infinity. Next step, I want to take the ln of all three pieces. I need to take the ln in order to get the x out of the exponential in the middle. So I have ln 2 less than the ln of e to the 5x less than the ln of infinity. Well, we can think about that in terms of limits. the hint there tells us the limit as x approaches infinity of ln of x is infinity. So we have infinity there. So ln 2 is less than 5x is less than infinity. Then we can divide both sides by 5, or all three sides by 5 rather. Infinity divided by 5 is infinity. Now we have x all by itself. We can make a statement about the domain. Thus, the domain is round bracket 1 of 2 over 5, comma infinity round bracket. Okay, so again, be careful with the difference between domain and range. For range, you want to make a statement about the function being between something and something else. You're trying to say that the y value of the function is going to be between two endpoints. And then for domain, somehow I've also numbered 1. For domain, you want to get a statement about x. X has to be between something and something. So they have different starting points and different ending points. Okay, third question is a limit. Limit as x approaches 3 of that expression there. Now, sometimes it's just a dirty trick. There's nothing to do except plug the number in. Always check that. So we're going to have 9 minus 4 minus 5, 0 over root 5 minus root 5. So that's 0 over 0. That's an indeterminate form. So we're going to have to do some type of factoring or conjugating. And this is one of those examples where we will conjugate. I'm going to multiply by the part of the expression that has the root in it on the top and the bottom. So let me just copy this down first. Just that. Okay, now I'm going to multiply by 1. The form of 1 I'm going to use is the duplicate of the square root term. But instead of a minus in between the two pieces, I'm going to change it to a plus. Okay, now the next step when we FOIL, we only want to FOIL the two pieces that look similar to each other. So in this case, I'm just going to FOIL the two bottom pieces because they look similar, because they're both square root terms. I'm not going to FOIL the top. If I FOIL the top, everything's going to get messed up. We will not see the cancellation that comes out. Okay, so I have a 3 minus x. I have a square root x squared minus 4 plus square root of 5. On the bottom, we have root of x squared minus 4 times root of x squared minus 4. That's just going to be x squared minus 4. Then we have the two cross terms that will cancel. And then we have the negative root 5 times the positive root 5, which will be minus 5. So we FOIL, and then cross terms cancel. Our limit operation is still there. Okay, and then I'm just going to simplify the denominator. Negative 4 minus 5 minus 9. And we still have a 0 over 0 because the 3 minus x on top and the x squared minus 9 on the bottom. Plug 3 into both of those, we're going to get 0 for the top, 0 for the bottom. So what I'm going to do 2 steps in the next line. First of those 2 steps is I'm going to factor a negative 1 out of the 3 minus x in anticipation of what's going to happen in the denominator. So I'm going to have a negative bracket x minus 3. Top term, square root of x squared minus 4 plus square root of 5. Bottom term, difference of squares, I'm going to factor it. X minus 3 times x plus 3. So again, that step of factoring negative sign out was done in anticipation of what was going to happen next, knowing I'm going to have to factor the bottom. I'm going to get an x minus 3, and nothing will cancel unless I factor a negative 1 out of that top term. All right, now what we have left is something we can take the limit of. So the negative is still there. We're going to have the square root of 9 minus 4 plus the square root of 5 divided by 3 plus 3. So negative root 5 plus root 5 over 6. Negative 2 root 5 over 6. And we can simplify a little bit. Negative root 5 over 3. Nasty. Nastier than it really should have been. Too hard. Okay, so next question is a limit as theta approaches pi over 2 from the left of e to the secant of theta. So I'm going to break this down into some steps. First of all, secant of theta is 1 over the cosine of theta. And the secant of pi over 2 is 1 over the cosine of pi over 2, which is 1 over 0. Cos of 90 degrees is 0, which is undefined. However, as theta goes to pi over 2 from the left, secant of theta goes to 1 over the cos of pi over 2 from the left, and in terms of the cast rule, I'm going to draw what pi over 2 from the left looks like. Pi over 2 from the left is equal to, or is like, 89 degrees. A little bit smaller than 90 degrees. That means it's in the A quadrant. And the cosine function is positive there. So this is going to go to 1 over 0 plus. Oh, 1 over 0 plus. So we have a positive number because the cosine function is positive at angles inside that quadrant. So this is really a positive infinity. So I'm going to pour all that in to this, that we essentially have e to the infinity, which is e multiplied by itself an infinite number of times. E is larger than 1, so 2.7 times 2.7 times 2.7 forever. So the answer is infinity. All right. Next question. Determine the value of k such that f of x is continuous at x equals 4. Continuous at x equals 4 means that so the definition of continuity is that the limit, as we're looking at continuity at x equals 4, so the limit as x approaches 4 from the left of the function to equal the limit as x approaches 4 from the right of the function to equal the value of the function at 4. Now looking at this function given here, the top part of the piecewise function is for x less than or equals 4, so this is for 4 minus and f of 4, so for the limit and for the value of the function at exactly 4, and then the second part, the bottom part of the piecewise function, for x greater than 4, that's for 4 plus. In the equality statement at the bottom here, what I'm going to do is I'm going to replace each of these components with the corresponding component based on the piecewise function. Taking a limit as x approaches 4 from the left, I'm going to select the piece of the piecewise function that corresponds to the left, which is the top part. I'm going to replace the 4 minus with a 4 because I'm capturing the fact that I'm approaching from the left by choosing the part of the piecewise function that corresponds to the left. For the second part, I'm going to do the same thing. The part of the piecewise function that corresponds to the right, I'm just going to select it. I no longer need to put 4 plus because I'm using the part of the function that is 4 4 plus. Okay, and then f of 4, that's the top part of the piecewise function. I'm going to replace the x with 4, so 4 squared minus 10. Okay, now I'm going to take the piece of the limit of those two pieces there. So 4 squared minus 10 equals 1 plus e to the 4k equals 4 squared minus 10. And then simplify, 4 squared is 16, 16 minus 10 is 6. Okay, and then the two pieces on the ends, the 6's, are the same. I don't need to carry them around anymore. So I can just say 6 is equal to 1 plus e to the 4k. This is redundant. Next thing we could keep it, but I'm not going to keep it. Next thing, I'm going to subtract 1 from all the sides. So 5 is equal to e to the 4k. And if we kept that other 6, we'd have equals 5 over there too, because we'd have to subtract 1 from that side. Next step, I'm going to take the ln of all the sides. I'd also have a ln 5 on the far right if I kept it. So just still duplicating that information. Okay, cancellation along the right. And then last step, divide both sides by 4. Thus, k is equal to ln of 5 divided by 4. And that is the value of k that we would use in order to make sure that the function meets that continuity requirement, that continuity condition at x equals 4. Any other value of k means that those two pieces of the piecewise function won't touch at that x coordinate. Their y values won't be the same. Okay, last question, aside from the bonus, asks us to show that two functions intersect between x is equal to 0 and x is equal to pi. F of x, so first thing I do is interpret this. F of x and g of x intersect means that f of x equals g of x inside the interval from 0 to pi. I'm going to replace f of x by its function, 2 times the cosine of x minus e to the x. I'm going to replace g of x by its function, x plus x times the sine of x. And the next thing I'm going to do is I'm going to subtract everything on the right side from both sides. I'm going to subtract x from both sides. I'm going to subtract x sine of x from both sides. The reason for doing that is I want to create something on the left equals 0. And then I'm going to call the thing on the left a new function, h of x. And then reformulate this problem as looking for the solution to h of x equals 0. Anyway, so let's subtract x and x sine x from both sides. So we're going to have 2 times the cosine of x minus e to the x minus x times the sine of x equals 0. I'm going to call all of this h of x. And now we want to show that h of x equals 0 has a solution inside the interval from 0 to pi. To do that, we're going to use the intermediate value theorem. Every component of this expression is continuous. The trig function, the exponential, and the trig times the polynomial, as well as the polynomial term all by itself. They're all continuous pieces. String them together, it's still continuous. To show that there's a solution according to IVT, I'm going to have to evaluate h at 0. I have to evaluate h at pi and hope that one of those calculations gives us a negative number and one of those gives us a positive. And then by IVT, there must be a number between 0 and pi that gives an output that is between negatives and positives, in other words, 0. Okay, so let's see what happens if I plug 0 in. 2 times cosine of 0 minus e to the 0 minus 0 minus 0 sine 0. Let's simplify that. 2 times cosine of 0 is 1. E to the 0 is 1. Okay, so we have 2 minus 1, which is 1. The important thing is that this is positive. Next, let's plug in pi. We're hoping to get a negative. 2 times the cos of pi minus e to the pi minus pi minus pi sine pi. So we're going to have 2 times negative 1 minus e to the pi minus pi minus 0. Sine of pi is 0. So negative 2 minus e to the pi minus pi. This is definitely negative. Bunch of negative stuff. And now, thus, since h of pi is less than 0, is less than h of 0, and h of x is continuous between 0 and pi, but it's actually continuous for all x, a solution to h of x equals 0 exists inside the interval from 0 to pi. It's okay to put the square brackets, putting round brackets, because we just showed that neither of those is the solution. H of 0 was not 0 and h of pi was not 0, so I can put the boundary a little bit better. Let's see. By intermediate value theorem, by IVT. Thus, f of x equals g of x inside 0 comma pi 2. Okay, last part is the bonus. What is the range of the sine of the arctan of x plus the arctan of 1 over x? Inverse functions give you angles. So if I look at, let's say the second one, arctan of 1 over x. That's going to give me an angle theta. I'm going to take the tan of both sides, use the cancellation law, and we get tan theta is equal to 1 over x. I'm going to draw a picture of that. What does that look like? Okay, so I'll put theta here. This is opposite over adjacent. So my opposite will 1, adjacent I'll put an x. And I'll put an hypotenuse up here, I'll call it h. Now the other statement is arctan of x. Arctan of x and arctan of 1 over x don't necessarily give us the same angle. I'm going to give it a different name. I'm going to call it phi. Take the tan of both sides, and I get tan of phi is equal to x, which is the same thing as x over 1. That's the opposite over the adjacent. Now if I look at the picture over on the left there, opposite x, adjacent 1, well that means phi is up here. Okay, so thus f of x is equal to the sine of the arctan of x, which I said arctan of x was phi, and then arctan of 1 over x I said was theta. So f of x is a sine of phi plus theta. Wait a second. But the sum of angles in a triangle must be 180 degrees. Now this is a calculus course. We don't work in degrees, we work in radians. So it must be pi radians. So thus, we add up those three sides, theta plus phi plus the right angle there. So pi over 2. Uh-oh, don't do that. Plus pi over 2 is equal to pi. Subtract pi over 2 from both sides. So theta plus phi is equal to pi over 2. So let's throw that into the theta plus phi there. So we have the sine of pi over 2, which is equal to 1. Thus, f of x equals 1 for all x. That's the range. It's always 1. There's only one y value that can possibly come out of this function. That's the y value of 1. Neat. Definitely a trick question, but neat.